Sure. How's that? Cool. All right. Hi, everyone. I'm Bobby Bickley. I'm a PhD candidate at UVic. And I want to tell you about a few specific cases over the course of my PhD where I found machine learning methods to be particularly useful in constraining the influence of galaxy mergers on the evolution of those galaxies involved. So the particular project that I'm going to tell you about today is about supermassive black holes and AGN in galaxy mergers. The first and maybe the most relevant way that we use machine learning in this work is for identifying galaxy post-mergers. These are extremely rare objects. They're less than 1% in the low redshift universe. And as a result of that rarity, there are a lot of issues with trying to identify them using conventional methods, or a lot of effort involved with identifying them by eye. Your hit rate is really discouraging when you try to do that. So we use a model. This one is just a pretty simple CNN, and we've used this here to identify a sample of around 1,000 post-mergers from DECaLS R-band imaging, and I've got, I think, 25 of them highlighted there on the right. So we use these because they represent the integrated effect of the entire galaxy merger on the evolutionary trajectory of that galaxy. So now we want to study supermassive black holes, AGN, in these galaxies, and we're going to do that using the brand new all-sky data release of the Rosita survey. So this is the new data set that we're working with, and prior to plugging this into our usual analysis framework and trying to study how common and what the characteristics are of these X-ray AGN in galaxy post-mergers, the first thing that I did was I plugged this into this deep self-organized map that I had created for SDSS DR7 galaxy spectra. This is a sort of autoencoder and self-organized map sort of trained all at the same time. It creates a lot of useful representations. It's quite similar to the tool that Peter was talking about yesterday, but it also comes with these nice template representations of the different types of spectra that come out. So we use this again, and what we realized is that a lot of these X-ray AGN from eRosita have very quasar-like spectra with broad emission lines and characteristically blue sort of emission, which is perhaps expected when you have a really high luminosity X-ray AGN. You're more likely to blow out obscuring material and glimpse the nucleus of the galaxy. So we know to include these galaxies in our analysis because of that, and so we do this. We find a couple interesting physical results about X-ray AGNs in galaxy mergers. And what I also want to mention before I run out of time is that coming soon, rather than just identifying galaxy post-mergers, so ones that have completed a merger and have these characteristic appearances, we're looking at doing temporal classifications using an ensemble model of 10 CNNs and 10 SWIN transformers trained on this really large data set that we've created. I'm working with my colleague Leo Ferreira on this, so you have that to look forward to. And I will end there. Thank you.
All right, thanks, Bobby.